Hello and welcome everybody. I'm Gabor. Uh, Here is Zoltan with us as usually, and this is the Strategic Impact Web3 podcast. This is our sixth episode, and we are continue our big topic regarding NFT launches. And today we will talk about the topic many of you waiting for and asking questions from us is how we should build up the technology side. As we once said, technology part regarding the NFT launch and the smart contracts must be solid. It's a really, really difficult thing, and you need to be aware about many things. You need to be aware how and where you are storing your assets, I mean, images and metadata. You need to be careful with your sites because there can be some scalability and availability issues. You need to consider the gas prices because it's a really difficult thing and it can have a big impact on your launch. You need to work with bots and against bots, as we said in the previous podcast. Also, there are many mistakes that can happen in this space, and we should learn from the others who actually burn themselves. And we will talk about how you can secure your contracts. And what's really important here is the cost of the deployments and transactions. So many topics for today. I'm pretty sure we won't be able to fit it into the 15 to 20 minutes what we promised in our first podcast. But as far as I remember, we didn't had any podcast which was in this time frame. This is how it is.
Yeah, wait until I
So,
go on my rant about NFTs.
yeah. But let's just jump in because many interesting topics here. First, we should talk about where will you store or assets, images, and metadata. What do you think about this, Zoltan?
Oh my! And now here it starts. So there is a very interesting problem about this. First, I'm just gonna give you the basically the options, and then we are going to talk about what an NFT is and what's happening today and what's wrong. So basically, your main options are going with IPFS or going with another distributed service like ARV. IPFS is the interplanetary file system, which is a distributed set of machines, nodes, which would be hosting your images temporarily. And there are some services on top of it, like Pinata, which are centralized services that will basically pin your data, make sure it's not just temporary, but it's more permanent. And then you have ARV, which is another piece of technology that is not permanent storage. It is not a temporary storage. It is a permanent storage. It's lifetime storage. So once you pay for a certain amount of data, it will be there for the rest of your life, or at least for several hundred years. But now
I think this is the first surprise for many people.
Exactly. So
temporary what?
Yeah, let's go back a little bit to NFTs because it's very important that in my rant that is going to happen now, I'm not going to try to attack NFTs. I'm trying to express an opinion and the technological insight on what is happening in the world of this NFT craze that's happening right now. So NFTs are non-fungible tokens, right? What an NFT does by its specification, look at the ERC 721 specification. You can find it in OpenZeppelin or an Ethereum website. It is basically nothing else. It's a token that you cannot split further. So basically, I cannot send you like half an NFT, right? I have to send you the entire NFT. And it's also unique. So your NFT from a collection is not the same as my NFT from a collection. So there is a limited number and they are always unique. This means they are perfect for expressing digital ownership. This is why they are becoming so extremely popular. It's a proof of ownership of something. You own something that you can also trade. And this is the power of NFTs. If you look at the standard, or if you listen to what I just said, I never once mentioned that it is a picture. And there is a reason for that, because NFTs are not about picture, it's about expressing that ownership. So how is it possible that right now everything in the NFT world is, a piece of art, it is representing an art, it is pointing to an art? Well, it is pointing to a picture. They have extended these NFTs to basically store a piece of URL that is pointing to a picture. Here's the problem with the picture. It doesn't fit on the blockchain. It doesn't fit in a transaction unless you do, let's say, an SVG that is like really small and really, really basic, like a stone, let's say, that you can store in an SVG code on the blockchain, the transaction. But if you have like let's say a 4K image or an 8K image that is like becoming more of a trend now, there's no way that's gonna fit on the blockchain. So you have to basically store in your NFT a reference to that picture, right? But then where are you going to store that picture? You can't store it on chain, so you have to store it off chain. So one of the services everybody goes to is IPFS, the Interplanetary File System, yeah, right? It's amazing. It's going to be storing your data redundantly. It's going to be there for how long? Actually, if you read the documentation, it turns out that if you want it to stay there, you have to host your own IPFS node as an NFT issuer, right? So the collection creator, you would have to run your own IPFS node, pin your data in there for the rest of your life. Well, that's not something that you will want, right? And me as an NFT collector is also not something I want, because then I will have to trust you to run that node for the rest of your life, at least as long as I'm interested in that piece of art, which should be technically forever because it's art, right? So that's a problem there. Why do you have to do that? Is because IPFS is using garbage collection. If there is a piece of data that is not accessed too frequently and it needs space, it will basically delete the data that is the least frequently used. So your data might be gone. So what can you do if you don't want to host your own node? You can use a centralized service like Piñata. That's what everybody is using today. Piñata offers a CDN and a bunch of services for actually not too much money, but it requires a monthly service. They will host IPFS nodes and they will pin your data for a monthly fee. And you will have to pay it for the rest of your life. And I will have to trust you that you will be paying it for the rest of your life. I also have to trust Piñata, that Piñata just won't go down and the nodes won't go down and they won't lose my data. Oops. That's a little bit of a problem, isn't it? So that's a problem with IPFS. Okay, let's not use IPFS then. So what about using Arweave? Arweave is a great piece of technology and it is designed to solve this problem. The only problem is that it's like really new. It's really, really new, right? We don't know if like 5 to 10 years from now it's going to be there or not. And then that becomes, a new problem. You will pay a one-time fee. I think like you can pay like $10 and you get 1 gigabyte or something. You have to pay in their own native coin, but it's roughly the amount right now. So it's more expensive obviously than Piñata, but it's not a monster fee. It's a one-time fee for which in return you will get your data stored for forever technically. So this is a basic problem, right? If for any reason that storage goes away, your NFT that was pointing to a picture and pointing to metadata that described the traits, which explains how specific and special and unique your NFT is, and is completely off-chain in this storage, and it goes away, then your NFT is pretty much useless.
Yes, so the owner will only have a URL.
Exactly. You will have a broken URL. Exactly, 100%. So what do collection owners do about it? Well, let me tell you this, 99% of the collection owners don't really care about this. But there's another thing that they do. When you issue an NFT collection and you have minted your NFTs and, all said and done, ideally, the NFT collection owner should release the ownership of the contract. What does it mean? The contract has a bunch of capabilities, functionalities that you can execute. One of them is setting the base URL, setting the URL where their data is. And only the owner of the collection, the deployer, let's say, deployer of the contract, can interact with it and can change that value. If they don't release the ownership, they will be able to do that 10 years from now. So let's say basic, the developer just wakes up one morning and says, you know what, screw you guys, I am going to break all of your NFTs, and just changes the base URL. They can do that if they didn't release the contract, right? They just call this set base URL, and then everything is pointing to nowhere, and you have a useless NFT. So that would be rough. This is why you should release the contract. And if you release the contract, nobody owns it anymore, right? It's there on the blockchain. It's fully trustless. You don't have to be afraid that somebody breaks it. But at the same time, if the data storage is broken, the NFT collection owner won't be able to update that URL, because the chance is still there. If the data storage gets corrupted for any reason, then they can re-upload that data, the pictures, the metadata, and point to a new place. But if they release it, if they release the ownership, then they can't do that anymore. So it's a good question, right? Do I release the ownership? If I release it, I won't be able to fix such a thing. If I don't release it, then let me ask you, where is the trust? I mean, where is the trustless aspect of this whole NFT world, right? I will have to trust you as an NFT collection creator that you will never do anything bad to my NFTs. And honestly, that's not trustless, is it? So
of course they don't do.
Sorry?
Of course they don't do.
Exactly.
Because everybody is talking about this is a wild west, and many bad things are happening here. So I think we should just summarize it for everybody, what's happening here. I think there are two crucial questions here. Do you have to store your metadata externally? Do you have to store your images externally?
Yeah. So that's a very good question. I would say if you can create an NFT where both your image data and your metadata being the traits, can be stored on chain, that's the real power. That's the real NFT. That's where you want to go. That's what you want to build. If you can't, then you have to choose something like either IPFS or ARV. From my perspective, ARV is a better option because it's supposed to be there for the rest of your life and it's trustless. However, it's very new. You can go with IPFS, but it will incur a monthly fee that you will have to do if you go with the pinning service, which you will use because nobody wants to run their own IPFS node. And that will be costly, and you have to do it for forever.
Yeah. I think we can move to our second big topic. It is your website, because on your websites, many things will happen. For example, for the private sale, you will have your minting page. You won't outsource it for example, OpenSea. You will do it for yourself, and it can create a lot of traffic. And we've seen many projects, even from big companies, huge companies, who wasn't able to handle this kind of traffic, and they had availability problems a lot. How they can prevent it?
Yeah, so when you are promoting a project and you create your first landing page for it, honestly, you don't have to worry about too much about traffic there, right? I mean, obviously, it's better not to run, a small server in the back of the corner of your flat. That's not what you want to do. But having a landing page, it's all fine. That's not where your problems really start. The problems where really start is the moment of minting, right? When you go, let's say, on a public sale. In your first 10 seconds, people will be sitting there, thousands of people, maybe tens of thousands of people, and hitting refresh for that minting button to appear so they are able to click on it. That's an insane traffic. That's a totally insane traffic. And it can be very expensive. I would say from a technological point of view, what you could do is one, for your minting page, try to avoid hosted services like Webflow and stuff.
Wix or Webflow.
So Webflow, because they won't be able to handle that traffic, or if they do, then it will cost quite a lot of money for you. So for your minting, for your landing page, it's totally fine. It's perfect because you can go really fast. You can create nice things. It's perfectly good. But for the minting page, where you are actually minting, I would suggest to do a client-only code base, React, Angular, pure HTML, jQuery, whatever you are good at, but just pure client-side only. Host it in on a CDN. Like for example, if you do AWS Stack, you can just put your client-side code into an S3 folder, put a CDN on front of it, CloudFront on front of it, and it will be served. You don't have to. There's no server-side aspect that you will have to worry about. It's just rendering the HTML in the browser, run some JavaScript, and that's it. You don't actually need a backend for 99.999% of the stuff that you are doing here.
Yeah. But what if you need?
Sorry?
What if you need? Sometimes. What if you need a backend for it? Sometimes it's needed.
Yeah, could be scenarios where it's needed. For example, if let's say you are doing whitelisting, and you do let's say on the pre-sale, let's say you have a button that you click on and it will check first on the backend if you are whitelisted or not, because you don't want to figure it out from making the transaction and then transaction failed stuff. That's not how you want to go, right? So what you want to do is know it before you actually try to mint that you are not on the whitelist. And the way you do that is usually just have an endpoint on the backend that tells you based on your address whether you are on the whitelist or not. And for that kind of stuff, again, something super lightweight, super scalable is really, really useful. That is also cheap. So, for example, in case of an AWS service, if you use Azure or Google, cloud, you have the same ideas. But for example, AWS, you would be using, let's say, Lambda functions which run the logic for you, and you would put an API gateway in front, to serve those HTTP requests, and you ask for an address, it will return you the JSON response. Yes, I'm in, or yeah, no, you are not in. And you might also want to consider putting, let's say, a web application firewall in front of it, because some bots could just start trying to guess addresses who are on the whitelist and stuff, and it could do like really weird stuff, and spend a lot of money, because if somebody, let's say, calls your web API, which would scale right now, because AWS, that's what they do for you, they would call it a couple of 100 million times, you would pay quite a lot of money there. So you might want a web application firewall in front of it that can do some kind of rate limitations and stuff.
Yeah. And the other thing, there will be other kind of hackers who will try to break your stuff from a different aspect. So be super careful with your permissions, and you need to set it a really good way, because there will be people who will try many things.
Yeah, absolutely.
It's a Wild West.
Yeah, exactly. I always say that, where the money is, that's where the attackers are, right? and
and there is a lot of money here,
right? If they can, they will. So you always have to make sure that once you have published your minting page, or your website for that matter, it has to be secure. Like, don't leave security holes in there where an attacker could go in and somehow hack your website, change your URLs, change your messaging, change the address of your contract, anything that they could cause damage to the user. So that it requires some actual technical knowledge to really lock that down. You need some skilled developers to protect your infrastructure.
Yeah. So let's just summarize what you should do with the website. First, if we are talking about your landing page, any solution can be good. Wix, Webflow, any of these. But the minting page is special because there will be a huge traffic on it. Maybe 10 or 20 or 50K for 10 seconds. That's a lot and many bots. So it should be placed on a CDN like S3 from AWS. If you need a backend for, handling the whitelist spots, then you should consider using Lambda and serverless technologies with some API gateways. Make sure you are protecting yourself with some firewalls because there will be a lot of bots and they will try to guess the wallet address and many other things. And make sure your infrastructure is secure and you are setting your permissions really well. This is crucial, and you need really smart guys in your teams who can actually do that. Otherwise, you can expect some people will come for your money.
Yeah.
Okay. Let's just jump to the next topic because it's also super interesting, the gas prices. And before we talk about this, there are two big questions here. What is gas and how is it calculated?
Right. So gas is, and okay, we have to point it out that while we are usually talking in general about NFTs and smart contracts, right now we are talking quite Ethereum specific. So what we are saying right now about gas and all that stuff, this applies to the Ethereum ecosystem. So on Ethereum, the gas is basically the cost of your transaction. Whenever a piece of logic, a piece of code needs to be executed on these nodes, in these smart contracts, then any operations that they do, calculations, adding numbers together, dividing numbers, moving money from one location, everything has a price of computation that's expressed in something called gas. So, for example, an NFT's minting logic will cost a certain amount of gas units. The gas price is, the price of a single unit. So it is very important that the gas price also fluctuates. How much gas you need to use for a logic, let's say for minting, is always the same, but how much it costs is always fluctuating because it's calculated based on the load of the network. So if roughly the logic is that if in a transaction block, the transactions only fill up 50% or less of this block, then the gas price decreases. If it fills up more than 50%, then the gas price increases. And what happens is sudden spikes. So when there is a minting happening, a public sale happening, then suddenly everybody wants to mint, right? So the gas price, because there's going to be so many transactions queued up, the gas price will start to increase. And then you are ending up in really, really interesting situations. That's when you might see that transactions fail. So why does a transaction fail? The transaction could fail because the gas price that you have allowed, the gas limit that you have allowed for a transaction to complete, that you are willing to pay for, because you can specify how much you are willing to pay for, how much basically you bid for this transaction to go through. It might be below the average that everybody else is paying. And if it's below, it will be pushed very far in the queue. That means your transaction will be picked up after everybody else's transaction is picked up. Maybe it will never be picked up, and your money is blocked.
I think there is a super interesting question here. What happens with the failed transactions? Still have to pay the fee?
Yeah, so that's what I'm kind of getting at. So what happens in case of minting? So you imagine that you are trying to mint one of those 10,000 NFTs that is available, right? And you have specified the gas fee that is too low. So everybody gets in front of you, which means that they will mint that 10,000 NFTs. Yeah, the gas price is higher, nobody picks up. No node will actually pick up your transaction. The sale is done, the gas price decreases. So now it's your transaction that will be, ready to be picked up, because now it's within the average that the network requires. but all the 10,000 NFTs are already sold. So you can't mint one. Your transaction will fail. The computation still has to be done by the node. So the money, the fee, the gas fee, has to be paid. So your failed transaction means what it means to you that you have lost the transaction fee. It's a bit unfortunate. That's how the system works.
Yeah, this is how it is. And there's another interesting question here that many people are asking on Twitter. What if we are adding whitelisted members and these members are trying to buy our NFTs in bulk? They want to buy 10 or 100 NFTs. Do they need to pay one by one and paying a huge price, or there are some smarter ways to do that and optimize on the cost?
Yeah. So I think once again this goes back to the original topic of the original NFT, and the standard ERC721 wasn't really designed for what people are doing today with NFTs. It was designed for minting a single NFT, and a contract that is like extremely popular, created by Open Zeppelin. It has been vetted, audited, and it has proven over time so many times. It's a secure, very well written smart contract to basically represent NFTs. But it was never optimized for this kind of stuff. It was never optimized for people who want to mint 10 at the same time, not just one. So that obviously means that if you mint 10 NFTs, you will have to pay 10 times the gas fee as you would be paying for just a single mint. So that's a bit unfortunate. The space is obviously trying to do a lot of experimenting on optimizing that, but the original ERC 721 implementation by Open Zeppelin doesn't account for that. So, for example, one thing the community has done, there was a very interesting collection at the beginning of the year called the Azuki collection, and one of the things that they did, they have created their own standard, which is fully ERC 721 compatible, but they have changed a couple of things in the background, how they are representing information, how they are retrieving data. There is some internal optimizations that they have done to the original 721 contract, and basically they have managed to change the logic for base minting. They're not specifying a token ID anymore. They are specifying basically a quantity during minting, which means that instead of minting when you are minting 5, instead of minting 5 times the gas price, you will still pay roughly the price of 1. Maybe a little bit of increase, but definitely not the price of 2, or definitely not the price of 5. So they have drastically optimized, let's say, batch minting with their contract. They have open sourced it. They have written a great article about it, explaining exactly how things are working, where they had, what kind of drawbacks they had to do. It is really important, and it's a big step forward. So people should be using that. But even today, you can see many collections coming out with the base ERC721, which just tells you that from a technical perspective, the project is not that sound.
Yeah. If you are one of our regular listener, you already know we really like the Azuki guys, and as we already mentioned, these guys know what they do, and this gives them a lot of credibility.
Absolutely. You look at the article, you know it's legit, right?
Yeah, these are super smart guys, not just random guys who's doing some art. They know what they are doing, so respect for them.
Yeah, absolutely.
Okay, so let's just summarize all of these things. You really need to consider the gas prices, and you really need to consider the changes in the transactions and all of these things. From developer point of view, there are many new ERC standards that create opportunities and optimizations for all of these things that you need to consider when you are building giveaways, whitelist, batch, minting, all of these things. So really, really interesting things are happening here. And we should go to our next topic, which is bots. And the bots are everywhere. And yeah, bots are trying to be there to mint directly from the contract, and they are pushing themselves in. And many of the people in the NFT space are using it. But how we can protect our site from them and from their traffic and many shady things they are trying.
You can't really. That's the sad answer. I mean, you can try to do all kinds of protections, but really, it's not that trivial to protect against it. For example, if your contract can be minted directly, without specifying any special keys, hashes, whatever, during a public mint operation, a mint public function or something. Basically, they say you can mint directly from the contract, which in 99.99% you can do. Then a bot can mint as well, but there's not much you can do around it. You can make it somewhat more complicated. You can require some special keys, special hashes, special computation to be passed in and validate on the contract side. You can do some magic stuff like that. It will not be impossible to hack that, but the moment you are publishing your contract, that's when bots will see it kind of first. And if your public sale and pre-sale are, let's say, within 24 hours, and they won't have the time to adapt to it, because your minting logic is more complicated. And also, of course, the pre-built bots where the developer actually doesn't control what they're doing, but it's just you bought it from somewhere, and you won't be able to update that to make it work with your with this custom smart contract, which has like tricky minting logic. So you can do tricks like that, but in 99.9% people don't actually apply these, and this is why bots are always winning the gas wars. They're always the first, to the point that recently I've seen projects where they announced that minting will be, public sale will be exactly at 8 o'clock in the evening, and you can already see at 7:29 sorry 7:59, like 1 minute and 2 minutes before, transactions being queued up by bots. So they're already playing on the fact that the team will release exactly at that time. They will flip the flag, and from that point on, you can queue, and they are the first ones there because they have actually queued up before it became public. so they are going for the fact that we will be the first ones. And it's really, they take a big risk, because if the team delays by 5 minutes, all those transactions will fail 100%. But they have the money to take that risks, and it's very hard to compete with that.
And it usually results in uneven distribution of the collection items. Do we care? Do the NFT collection releasers care?
Yeah, that's the question, right? If all your goal is just to sell out, and there is no real sense of community building behind your project, then I guess doesn't matter. I guess the only thing matters for you is that people buy it, at least on secondhand market, and they do some more transactions with it. It's sold out, so why would you care as a collection creator? But if you're trying to create utility around it, if you're trying to create a community around it, that having an uneven distribution is really unhealthy for your project. You want active collaborators. You want to have not a 1-to-2 ratio, not a 50% ratio of holders to of supply, but somewhere closer to 0.8 or 0.9. The closer you are to 1-to-1 is the best. You want to have many people in your project. So yeah, you have to ask your questions. Do you care if bots will take it? There's going to be a small backlash, but people are not used to it, that bots win, and they get disappointed. There won't be that much of a backlash. But if you want to have a community, you need to care.
Yeah, Yeah. Okay. Our next topics is securing your contracts because, as we mentioned, many things during this episode. Many people will test your contract. Some of them are with bad intentions.
Yeah, absolutely.
What are the options to actually secure the contract?
Yeah. I mean, go to Etherscan, look at any of the NFT collections contract, what people are doing manually or using bots before your pre-sale or before your public sale. They're already trying to mint, right? They are trying to find those loopholes in your code. And it is very important that once you have published your contract, you can't really update it, right? There are upgradable contracts, but nobody's using it in the NFT space. It's quite complicated. We'll not go into that topic right now. But the point is that if your NFT contract is there, you can't really update it. If there is a bug, then you have a problem. So the main thing that you can do with your contract is to audit it. Writing a smart contract by one developer in the back of the corner of a room is the perfect recipe for disaster, right? You want to have multiple eyes on it. At a minimum, have it peer reviewed by other small Solidity developers who have written something like that. But ideally, you are using an auditing service. For example, Open Zeppelin does security auditing, and they look at your contract and they check out if everything is fine and they identify issues for you. That's one thing that you can do, and having some level of audit is very important. The other thing is that the contracts in Open Zeppelin 721 or the contracts implemented by Azuki, they are safe. They are well written. They have been vetted. They have been audited. They have been tried now in the Wild West, as many people say. So the more you diverge from it, the more risky your implementation is. The less extra you put in there, the more safe you are. So just try to keep close to that structure. Don't reinvent the wheel. Use the existing libraries, the existing standards, the existing contracts. Just build on top of it, so at least the base, the foundations are strong. So that's definitely something that you can do.
Yeah. Just summarize all of these things. So first, consider the standards. Use the Open Zeppelin implementations and don't diverge much from those because maybe you are not knowing what you are doing here. Verify your contracts on Etherscan and ask for an audit. And
Yeah, absolutely.
ideally, you should release ownership.
Yeah, that's the thing. Ideally, you should release the ownership, but that's how we started the conversation, right? If you release the ownership, you can't update the contract, for example, the base year anymore. So you might be in a little bit of trouble. So nobody really does that. But until you release the ownership, it's my NFT is not really mine until you release it. So it is a tricky business. But yeah, looking at your smart contract, making sure it's sound and security is very important. Just recently, I've watched a project like really closely. I was quite involved with it, and they were planning for a public sale. And then I was looking at the contract code. I was like, how they did it, how it works, and I realized that oh wow, that's interesting. There's quite a big security issue with this contract. Basically, I can mint until the end of the days. Like, what's going to happen here? And on the same day, they actually announced that instead of a public sale, they are gonna be doing a raffle. If somebody doesn't know, raffle is basically you sign up for a spot, and it's kind of a lottery. You might get a spot or not. The raffle logic allowed them to use the exact same methodology as they did for whitelisted minting, and not to use the public mint function. And when I got in touch with them, explaining them what kind of issues I found in the public minting, logic, they said that they have kind of realized it, but they are doing raffle now, so that doesn't really matter anymore. Well, I'm pretty sure that they are doing the raffle because the public mint function was completely broken, right? They actually had quite a bit of backlash from the community, changing the rules and changing the promises of how the public sale / raffle will happen, but they didn't really have a choice. Like, public sale was never going to happen for them. So you have to really make sure that your contract is bug free and secure.
Okay, I think we summarized this topic very well. And there is another topic that many people asking on Twitter and on other forums, and this is the cost of deployment of contracts and the cost of transactions. Maybe we can give some guidelines regarding these.
Yeah, so the more stuff that you put into your contracts, the more functionality you are adding in there, the more base contracts you're using, the more libraries you are using. It is going to become bigger and bigger and bigger, and the initial deployment will cost more and more and more. But we can tell you that right now, an ERC721 contract costs roughly like 0.4, 0.45 Ethereum, something around that. Obviously, it always depends. So you're talking about a gas price, really. It always depends on the traffic on the network. So if you are trying to deploy at the same time, then like there's a huge collection coming, then it might be like 10 times that. But if you are trying to deploy in a kind of a quiet time, then it's roughly like 0.4 Ethereum. And again, the more functionality you put in there, the more expensive it's going to become. So just try to minimize and don't include the libraries. Don't include code in there that you don't need, and then you will save yourself some money.
Yeah. And during the episode, we have mentioned some good examples here, but there are famous mistakes here and embarrassing moments. We should really talk about these a little bit. One of them are Asuna, and you can learn a lot of this. They actually published the address of their test contract, and the people were transferring money there. They spent hours to return the money to the people, and of course, there was transaction fee on all of these things. So they paid actually a huge pile of money to fix this issue here.
Yeah, I mean, again, I think we have mentioned this before. Absolutely hats off to them because they did the right thing, right? They said, okay, stop everything, and whoever had damage, we will immediately refund it, even though the transactions fee we will have to pay for. So they have fixed everything, and it was highly respectable. And they have later explained what really happened is basically during deployment the test contract address didn't update to the final contract address, even though they have made the update when they did the deployment and switched the environments. It just didn't happen. Now, and I don't want to be too critical of them, but this is where you will have to make sure that from a technical standpoint, you really know what you're doing, right? When you have something, cached from a domain through a CDN or by your browser, then you can't be surprised that a value just won't change. That's not how caches work. Caches do expire. Caches you use, e-tags and stuff. But just because you change an underlying value on exactly the same address, it's not gonna invalidate. That's not how a CDN. That's not how a cache works. So honestly, it's just from a technical perspective, you need to have good developers on your team who understand what they're doing. Otherwise, it will cost you insane amount of money. And this is happening everywhere. It happened. This was quite embarrassing for us, but they came out of it. We mentioned the previous issue about having to change on a project the public sale into basically a whitelist again. That is quite embarrassing. But other brands had really serious issues as well. There were many delays, for example, on the Gucci with a team called Super Plastic, who should be quite experienced now. Adidas had quite rough moments with their first rollout, but even in the second rollout they had problems, and all of them are technical issues. Every single one was a technical issue. And this goes back to the entire topic that we are talking about today, is that this is not the usual point and click stuff. I mean, you can do point and click stuff, but then you'll get burned. All of these projects got burned. So you should just make sure that you know what you're doing.
Yeah, and I would like to highlight something here. We are not, our intention is not to point finger on them and saying, "Ha ha, how stupid they are."
No,
This is
absolutely.
not the thing. We want to learn from these mistakes, and we want the community to learn from these mistakes and not repeating it, because this is the way to create actual value for the community, for the creators who's doing these NFTs, and this is also create value for the guys who's actually buying it, because our intention is to make this whole space less Wild West.
Exactly. I mean, all the things that we have been talking about, optimizing your contracts to reduce gas wars, coming up with strategies to reduce gas wars, trying to lock out bots, again to reduce gas price, securing your contracts to make sure that your money won't be stolen and you don't have bugs, but you will have a seamless rollout, implementing an infrastructure and securing an infrastructure that can scale and will stay available, and it won't be penetrable by hackers. All of these contribute to a really smooth rollout, and you just have to look at all of these aspects and make sure that you follow these best practices that the engineering
Yeah,
world has been doing for decades now.
yeah. You may remember the first episode we mentioned that all of these are still super early stage technologies.
Very early stage, extremely early stage.
These are baby steps here, and there are still a lot of works need to be done by smart people who's actually willing to make it better and better every day. And I see many good intentions here. So I would like to say for many people, keep up the good work and go through this phase. I hope we helped you a lot with this episode. Tell us in the comments. You can also tell us if you didn't like it or you didn't find relevant information in it. We are really curious what you think. So don't hesitate to comment. And thank you very much for listening us. Thank you very much if you are one of our frequent listeners. So see you in a few days. Cheers,
Yeah.
guys. Bye bye.
Bye bye.